Okay, starting with percent error today. This is still part of the first section. Yeah. Percent error is a mathematical calculation of the difference between the observed value, also known as the experimental value, and the true or accepted value. So it's a mathematical comparison between the observed and the true value. Are we ready? Everybody not ready? Okay. Okay. Example. So a student measures the boiling point of methyl alcohol to be 66.0 degrees Celsius at normal air pressure. The true value is 65.0 degrees Celsius at normal air pressure. What is the percent error? So we're going to go over how to do this in just a second after we get this written down. Yes.
What is normal air pressure?
That's a good question. I'll have to get back to you. I'll Google it. At sea level on the Earth, it is about 14.7 pounds per square inch. We ready to do this? We got this written down? Okay. So percent error, write this equation down, is calculated by taking the observed value minus the true value and then dividing that by the true value and multiplying by 100. So in this case, what is our observed value? 66.0 degrees Celsius. And what's the true? 65.0. Okay, so you take 66 minus 65, and then we divide that by what? By the true value. What's the true value? 65.0. So what is 66 minus 65? 1.0. Because if we look at sig figs, if we're doing subtraction, how many decimals should we have after, or how many figures should we have after the decimal point in the first one? 66.0 divided by, or minus 65.0 should be what in sig figs? 1.0, because we're doing, there's one figure after the decimal point, so it should be 1.0 divided by 65.0, and that answer we are going to take times 100. What do we get? Anybody do it in the calculator yet? Okay.
That's nice.
Okay, so we have like 1.538. How many sig figs are in 100? One. So I asked you for the answer in sig figs. 2% error. So if I asked you to figure out how much a hippo weighs, and you said, based on your measurements and everything, you said that it weighs 367 pounds. We're going to do another one. So this is your observed. But the true value was 672 pounds. Yeah, you all were really wrong on this one. What am I going to do? What's my first number? 367 minus what? 672 divided by what? 672. What do we get? Negative 45.3869. More numbers going out. If I ask you to take it to one sig fig, how would we do that? Negative 5. Because this rounds up, right? Negative 5 times 10 to the 1.
Why would you do it right if you don't take it and not just make it should be? Because you only have one sig fig.
Because
the adding 0 is not significant.
that's fine, you do that. That'd be fine. Oh, you didn't put a decimal point there. Or, so there's negative 15. But if I put a 0 here, how many sig figs do I have? 2. So it would have to be the 1. Either way, as long as I have the right amount of sig figs, I don't care. Okay. Questions about figuring out percent error? So ways of expressing uncertainty. First one is significant digits or significant figures or sig figs, because you can only be as certain as your sig figs allow you to be. You can't be any more certain than that. And then the second one is plus or minus notation. So in your percent error, if you are plus or minus 5%, you're way off and you need to fix it in order for your experiment to be accurate and precise. You can just type plus, slash, minus if you want. Okay, we're gonna watch this video really